So here's what we do. Here's what we do. Now, how many people have done something like this in maybe chemistry class? Anybody? Okay, if not, you will. You're going to be, I know you have occasion to solve linear systems in chemistry. If you're in physics, you do it in physics. You do it in science a lot. And I know that Mr. Cooper in his chemistry and physics classes teaches students how to do this. I'm not sure what method he uses. I'm not 100% sure. It may be that he uses what I'm showing you right here, but it may not be. And if it's not this way, I can tell you right now, this is the best way, at least in mathematics it is, because it accounts for all kinds of situations. Whereas if I just use a straight matrix equation like we talked about the other day, it works fine if you get a normal answer with a value for each variable. But if you don't, you get a weird answer, it doesn't do you any good. It doesn't tell you what kind of weird answer it is. By weird answer, what do I mean? Now, they're just like with regular lines in a two-dimensional space. These are lines in a three-dimensional space. What does this mean? I mean, what are the possible outcomes we can think about the kinds of answers that we got when we solved linear systems by crossing the lines on the calculator or algebraically. There were really three possible outcomes. What was one of them? The lines were, well, maybe they crossed at one place, in which case I just got a single answer, an x and y ordered pair, right? Okay, well, the other thing that could have happened was, and if I get a normal answer, in this case, I'm going to get an ordered triple. Instead of an ordered pair, I'm going to get an ordered triple, which is going to be an x, y, and z, grouped together, x value, y value, z value. The other thing that could have happened is we might have had no solutions. What if the lines were parallel in the plane? Or now, maybe they're just skew in space, or parallel, so they never cross. What's going on there? Well, this will tell us. It'll tell us if that happens. The other possibility was, what if the lines overlapped perfectly, and they were the same line, we had infinite solutions. Now, this is a little more complicated, because these aren't necessarily lines. These are actually planes, and it's a little bit more complicated. But we'll get into that stuff later, but we can still interpret the results in the same way. And that's what's crucial here. So how do you do this? Well, we're going to enter all of this stuff in a single matrix that's called an augmented matrix, just so you know, that's the name. So we're going to have, in this matrix, we've got three variables in each row, and we've got a constant at the end. So we need to have 4 columns to accommodate the coefficients of x, the coefficients of y, the coefficients of z, and the numbers, the constants on the other side of the equation, and just 3 rows for our 3 equations, right? So we're going to go second matrix. We're going to go over to edit, and we'll edit matrix A to be a 3 by 4, 3 rows and 4 columns. Okay, and then we're just going to go ahead and in the first column we always enter the x coefficient. Second column we enter the y coefficient. Third column we enter the z coefficient. And then the fourth column we'll enter the number. So what should the entries be in that first row? 2. Good. -4. 9. 18. And when I hit enter, it jumps me down to the next row. Okay, what goes there? Okay, good. 0. How come 0? Yeah, there's no y term there. So if we're missing a y term, what must its coefficient be? 0, right? It must be 0, because multiplying by 0 makes it 0, and so we wouldn't even include it. So if you're ever missing a term, you have to include a 0 coefficient. So we get 6, 0. Then the third column, my z coefficient is -5. And then finally, -9. Hit enter, and it jumps me down to the third and last row. -1, 4, 9, 6. Okay? Once I get them in there, I'll just quit. All I have to do is go second matrix, scoot over to the math menu, and what I want to do, I want to do a math operation called reduced row echelon form, which is, not that you need to know about that stuff now. Later on in college, when you take linear algebra classes, you'll talk more about this stuff. But all that means is I want to choose the operation that is RREF on the calculator, which is way down at the bottom. The quickest way to get there is just hit the up arrow to skip down to the very bottom of the menu. And it's option B. So I'll just move up to B. RREF, not REF. That's different. It has to be RREF. Okay? So I'm going to choose that one, and it's going to open up a set of parentheses. What do you suppose I put in the parentheses? A matrix A. Yeah. So I'll just go second matrix A, close the parentheses, and hit enter, and it gives me an answer. Now this is, let me show you how to interpret this. This is really important. When you look at this thing, notice that the first 3 rows and columns look just like an identity matrix, right? I get that diagonal from upper left to bottom right that are all ones, and every other part of that first 3 by 3 square matrix is a 0, okay? And then the fourth column, though, is a bunch of numbers. Now think about what these equations mean. We said that column 1 is the coefficient of x, column 2 is the coefficient of y, column 3 is the coefficient of z, right? So that first line, that first row, really just means the equation 1 times x, no x or no y or z terms, just 1 times x equals negative 0.3716, blah, blah, blah. So that's telling me the x value, isn't it? Right? So this first number corresponds to x. The second row gives us the equation 1 times y equals negative 1.639, blah, blah, blah. So that's telling me the value of y. And the third row is telling me the value of z, right? So that's what we might call a quote-unquote normal answer in order triple. A value of x, value of y, value of z. Okay? Now in Moodle, in this case, they wanted us to solve for x. So we would just use the first number only. But we could just put that in as negative 0. They want it to 3 places, so 372. Okay. And we got it. Okay. All right. Now let's look at a weird case, though. Let's look at one that doesn't work out normally. Was that a weird enough case?
Yeah.
Okay, let's try. Okay, so everybody try this one real quick. Put this one in for matrix A and see what happens. Okay, and I want you to solve for x. Yeah.
I got this.
Oh, and I you know what? I shouldn't have cleared that. Let me roll that back. Okay, so there's my answer. Now I'm going to leave that up here so I can go up and recycle it. Because I know I've got that already written in there. So I'll go second matrix, edit matrix A, and I'll just make these my coefficients now. Everybody get that in there? Okay, so now if we quit, look how easy this is. If I quit, if I'm doing a lot of these problems, all I've got to do now that I entered the new matrix A is I can just go up and highlight that RREF of A, reduced row echelon form, hit enter so it pulls it down, and I'll just hit enter to do that, and it gives me my new answer. Pretty slick. Okay, now look at the difference here. This is not a normal answer, is it? Look at the results. I end up getting not the descending diagonal, upper left to bottom right with ones and zeros everywhere else. So that tells me immediately if I don't get the normal result, then either this is a no solution or a many solution answer. To know which one it is, so if it's not normal, you just read the bottom row and that tells you. If the bottom row is a true statement, then it means many solutions. Put that away, please. If the bottom row is a false statement, it means no solutions. Well, look what it says here. It says 0 plus 0 plus 0 equals 1. False statement. So that's telling me that this is a no solution answer. And what Moodle tells you is that if it has no solutions, you enter 999. Okay? No, we're not quite ready. Okay, so now I know that's no solution, it worked. Okay, how about this?
Oh, okay, I get it.
No, a little different. Try this one. Okay, try this one. So if we quickly put this one in there, so second matrix, edit, A. So read these off to me real quick. What do we get? 2, 3,
8, 1, 6, 9, 8, 4.
oh, hang on. 8. What's after 8? 4. Then what? 6, 5, 2. Okay, so that one's in there. Now watch this. Watch this one. If I quit,
Mr. Cooper, you Mr. Way, you messed up on one.
I did. Are you sure?
Yeah. You got 8 instead of 3.
Yeah, you did.
Oh, I did. Okay, I need to fix it. Okay, so where should it have been?
Right after negative 1.
After negative. Oh, okay. Ah, 3. Okay. There we go. Yeah, you're right. All right, so now I'll quit. I'll just go up and grab the RREF and pull it down and hit enter. So go up and highlight it, hit enter again, and there's my answer. Now look at this one. Look at this one. PJ, you getting all this? Okay. So if I want to check the first 3x3 part, is it normal? No, it's not. It doesn't look like an identity matrix, right? It's not ones and zeros. It's something else. So I look at the bottom row. This time I get a true statement. 0 plus 0 plus 0 does equal 0. So this one means many solutions. Now you can't see this because it goes off the screen, but it tells you on Moodle, if it's many solutions, you put in 888. Exactly. Okay? So, right. Yeah, if it's one solution, it looks, remember, it's one solution, so we got it right. One solution, it looks like this. Let's just roll up here. And okay, there it is right there. Right, that's one solution. First three rows and columns looks like an identity matrix. Okay? It has to be ones. Has to be ones.
Whoa, that's trippy.